Hi guys. So let's talk about exponential functions and sequences. We've got a test coming up in Mrs. Johnson's algebra class tomorrow. And so here's our review. So problem 1 tells us that Carl Gossel is a machinist and he bought some new machinery for $125,000. The machinery depreciates at 15% per year. For part A, we have to write an exponential function for it. And then for part B, we have to figure out what the value would be after 10 years, after we purchased it, or he purchased it. Okay, so let's identify some numbers here. $125,000. This is going to be our A, okay, or A sub 0. This is our starting value, okay. This is, its original worth, its initial value. Any of those words work, okay. And depreciates means it's going to go down. And at 15%, this is our rate, which we're going to change that to a decimal. So it's going to be 0.15. And when we talk about depreciating with a rate, it's going to be 1 minus the rate. Okay? So then our function is going to be f of x equals 125,000 times 1 minus 0.15 to the x power. Now, if you want to simplify that 1 minus 0.15, you can. And so that you would get 125,000 times 0.85 to the x power. Now, either of these two equations you could put into your y equals of your calculator. Or for this next part, if you want to, you could just put it in the main screen, but instead of x, you're going to put a 10. Because this 10 here, this is going to be our x. So f of 10 is 125,000 times 0.85 to the 10th power. And when we do that calculation, we find out that after 10 years, that machinery is worth $24,609.30. And we want to make sure we put that 0 there because it's asking for the nearest penny. Okay? When we look at example or problem 2, we're asked to identify the domain and range of the graph. Okay? Now, if we look at this graph, there's no situation that's being addressed here. There's nothing telling us that cupcakes baking or that something is going down in value. All we have is just a regular graph. Okay. As a matter of fact, there are even arrows at both ends of the graph to tell us that it keeps going in both directions. Okay. So we're going to do domain and range both verbally, meaning in words, and in inequalities. So we're going to use symbols. Now, remember, our domain is our x values and our range is our y values. For our domain, because it keeps going in both directions and there's not a situation to limit that, our domain is going to be all real numbers. And when we write this in symbols, it's x equals all real numbers, that fancy R symbol, okay? When we talk about range, we have to remember that exponential functions have something called an asymptote. And that asymptote is right here at the x-axis. It's that y equals 0 equation. Okay? That asymptote is a line that our exponential function will never cross. No matter what we do, it's never going to cross that line. Okay? In Algebra 1, our asymptote is always going to be at y equals 0. But later, when you get to Algebra 2 and you start doing transformations like shifting up or down, that's going to change your asymptote. Okay? So for right now, we notice that our y values are going to continue to go up, and they're going to continue to get closer and closer to 0 without ever actually getting to 0. So our range is all real numbers. Hold on, I need to move where that's going there. All real numbers greater than 0. And when we talk about our range in symbols, just y is greater than 0. Okay? All right, let's take a look at the next page. Let's look at number 3. Okay? The value of a home purchased in 2012 is given by the function f of x equals $226,000 times 1.0.025 to the x power, where x represents the time that has passed in years since the house was purchased in 2012. Okay? And it's asking, what does the value of 226,000 in the function rule represent in this situation? Okay? Well, if you think back to when we were talking about Carl's new machinery, that number that goes out front of the parentheses right here, that's our initial value. Okay? So this is the initial value of the home. And this was in 2012. And the value of 0.025 in the function, when we look at our equation, it's 1 plus that 0.025. So that tells me that this number right here is our rate. Okay? So this is the rate of increase in value. Now we could change this to we can change it from a decimal to a percent just by moving that decimal over 2 places. Okay? And we'd actually get 2.5% as our percentage rate. Okay? The Mendelssohn Stradivarius violin was estimated to be worth $1,700,000 in 1990. And the violin is expected to increase in value by approximately 7.5% each year. So we're going to write an exponential function in the form of f of x equals a times b to the x power to represent the value of the machinery after x years. And it's asking for our asymptote equation. Now, before we even write the equation for our function, remember our asymptote equation is always going to be y equals 0. Okay? For our function, our a value is going to be what it was estimated at in 1990, because that's the starting value that they gave us. Okay? So 1,700,000 times. And our b value, that's our factor. We're going to find our factor by taking our rate. And because it's an increase, we're going to add it to 1. So 1 plus our rate. 1 plus 0.075 to the x power. And again, you can add that together and get 1.075. Okay? So our a value, we said, was 1,700,000. One more 0. There we go. And it represents the initial value of my pen is not going to cooperate with me today, so let's fix this. The initial value of the violin in 1990. Okay. Now, because it's increasing, this is a growth. Okay. Our rate is 0.075, and that represents the rate of growth. The rate of value increase. And our factor, we did 1 plus 0.075 for a total of 1.075. So we need to estimate the value of the violin in the year 2010. So to do that, to find our x value, we're going to do 2010 minus 1990. I forgot a 9. And we get 20. So we're going to do f of 20 is 1,700,000 times 1.075 to the 20th power. And when we put this in our calculator, we find out that the Mendelssohn Stradivarius violin was worth $7,221,346.87. Okay, it's kind of an expensive violin. All right. Question number 5. Susan bought a car with a value of $21,500. If the car loses 12% of its value every year, then we're going to complete the rest of this information, okay? So, of course, even if it doesn't lose that value, we're still going to complete the information, but, you know. All right, so bought a car with a value of $21,500. That's our A. That's our start value, you know, how much it was when she purchased it. It loses 12%, so 12% is our rate. That's going to become 0.12. So when we say it loses, we're going to do 1 minus the rate for our factor. The function that represents the value y of the car after t years, so y of t, is going to be 21,500 times 1 minus 0.12 to the x power. We could simplify this subtraction here. So 21,500 times 0.88 to the x power. Now, we want to graph the function. Okay? This is the part where if you have your graphing calculator, you really want to use that. Okay? You can do this with the calculator in your phone. You just have to keep multiplying by, you know, whatever the current value is by 0.88. Okay? So in your calculator, if you were to put this in y equals, these are the values that we're going to get for the first couple of years. Okay, so at year 0, we get 21,500. After year 1, it's 18,920. After year 2, it's 14,652. Okay. I'm sorry, I take that back. No, after year 2, I was looking at the wrong line on my paper. After year 2, it is 16,650. Okay, so we're going to start by graphing 21,500. Now these lines are every 2,000. So here's 20,000, here's 22,000. 21,000 is kind of right here in the middle, and 21,500 is going to be right there. Let me make my pen a little bit bigger so it's easier to see these points, okay? So 21.5 is going to be right there. Okay? And we're having to estimate where they are because, I mean, we had to fit numbers on the graph. We're not going to be able to get exact, but we could get a good estimate. Enough to get the shape that we want to look at. Okay? So here's 18,000. 18,920 is going to be just above that line. Okay? 16,650. Here's 16,000. So about right there. I have some more points written down on my paper that I'm looking at. So 14,652 would be after 3 years. There's 14,000. So we kind of need to go up about right there-ish. After 4 years, it's 12,893. And 5 years is 11,000. So let's see, there's 10, 11, it's halfway. 340, so a little more than halfway. Okay. This isn't perfect, but it's there. Okay. And if we just kind of connect our points, we see that it's kind of going like this, and it will continue to do so. Okay. Give it a little bit of a curve. Hold on. I lost some of my curve there. Okay. Exponential functions do have a curve to them. They're just kind of hard to see sometimes, especially when it's on a graph like this. It looks really flat, but there is a curve to it. Okay. So we want to estimate the value of the car after 6 years. Well, if we go here, kind of go up to 6 years to see where it comes out. It looks like it's a little bit over 10,000. Okay. So we could say that we're going to estimate it at about $10,000. It's just looking for an estimate. It doesn't have to be perfect. Okay. All right. So let's look at the next set of questions. We're talking about sequences now. Okay. So for each sequence, we're going to figure out if it's arithmetic or geometric. We're going to identify the first term and either the common difference or common ratio. And then we're going to write an explicit formula. We're not going to, it asks for a recursive formula. Okay. We'll kind of, we're not going to worry about writing a recursive formula, but I do want to make sure you understand the explicit formula. Okay. So determine if it is arithmetic or geometric. Now, arithmetic, remember, we're going to add the same thing each time. Geometric, we're going to multiply. Okay. So if we look from 9 to 3, and then 3 to 1, and then 1 to 1/3, we're multiplying by 1/3 each time. Okay. We're dividing by 3, but when we're talking about arithmetic or geometric sequences, we divide. So we just change it into a fraction and multiply by the fraction instead of dividing. Okay. So because we're multiplying by a fraction, it is geometric. Our common ratio is 1/3. Okay. And the explicit form that we're going to use is a sub n equals 9 times 1/3 to the n minus 1 power. Okay. And then when we go look at number 7, the last problem on our review, we have -1, 1, 3, 5. So if we look from -1 to 1, we added 2. And then from 1 to 3, we added 2. And from 3 to 5, we added 2. This makes it an arithmetic problem because we're adding the same thing each time. And our common difference is positive 2. So this should say explicit form. Let's call this our explicit form. Is a sub n equals negative 1 plus 2 to the n minus 1. Okay. Now, we did talk about recursive form in a previous video. So real quick, let me show you what the recursive forms would have been for each of these. Recursive for the geometric would have been a sub 1 equals 9, and an a sub n equals a sub n minus 1 times 1/3. Okay? When we talk about arithmetic, the recursive form, again, would have started with a sub 1, in this case equals negative 1, and our a sub n would have been a sub n minus 1 plus 2. Remember, this a sub n minus 1 in both cases is just whatever the previous term was. So to get the next term after 5, I would add 2 to 5 and get 7. And then I would add 2 again and get 9. That would be our recursive form. Okay? All right, guys. I hope you got some help out of this. On Friday, April 12th, 2019, my algebra students will be taking their test over exponential functions and arithmetic and geometric sequences. If you have questions, guys, you can send me a note via Remind, and I will see you guys tomorrow.